Hello, it is an audible. हेलो,
यस सर।
क्या हो गया बेटा? आकाश क्यों इतना लेट ज्वाइन कर रहे
हाँ
हैं सर? लास्ट लेक्चर लेट खत्म हुआ क्या?
हाँ ऐसे सर क्विज है ऑटोमोबाइल वाले का।
कभी था क्विज उनका?
पता नहीं सर, मैं सीएफडी में था ना, तो हम लोग का तो हो गया था।
अच्छा ठीक है, बहुत लेट, ऑलरेडी 12:35 हो गया, अभी भी ज्वाइन कर रहे तो ठीक है। चलो विल स्टार्ट एंड लेट देम ज्वाइन। Okay, in previous lecture already we have discussed about the rolling contact bearing and different types of rolling contact bearing, working of the sliding contact bearing, and after that we have seen the static load carrying capacity and dynamic load carrying capacity, and what is the different criteria to find out the dynamic load carrying capacity, and already we have seen the what is the L10 life, what is the LH life, how to calculate the reliability, and how to compare the L10 and L50. So after comparing the L10 and L50, we have gone through this formula to get the value of L with respect to L10. If you know the value of L10, you can find out the L. L means what? You can find out the life for any point. Any point means if you want to find out the life for 50, life for the 40, life for the 80, you can find out, but that time you must know the value of L10. If you know the L10, you can find out this term. If you know this term, then you can find out the L10. So vice versa, you can find out the life by this formula. So this is nothing but the life formula. And after that, we have seen the equivalent load calculation. Here we are going to see the how to combine the radial load as well as axial load. So while combining the axial and radial load, that time we must know the value of x and y. This x and y is nothing but the constant of radial and axial. V is nothing but the inner race rotation factor, and when inner race is rotating, that time we are taking this factor is 1. If that outer face is rotating, that time we are taking where factor is 1.2. So this factor is very important. Most of the time if you are going to see the PSG formula, then there's V is missing and KT is missing. That KT is nothing but the temperature constant. So if temperature constant term is given in a question, so we need to calculate. If this KT factor you are considering 1, or if you are not considering KT factor, it means what? This formula you are applying at the room temperature. Now this is a service factor. Here we have a different service factor. Same service factor formula is given on the PSG. PSG पे भी दिया है तुम्हारा on the PSG table number 4.2 पे. You can find out this safety service factors. So here you can see 1.2 for the steady load, 1.6 for the light shock load, 1.9 for the medium shock, and 2.8 for the heavy shock. And with that, we have considered the one by one example. Now this is formula to calculate the KT factor. This KT factor is nothing but the temperature factor. This temperature factor is nothing but the 1/1 minus percentage decreases in capacity. This percentage decreases in capacity we can find out from the PSG page number 4.2. And how to calculate this decrease in capacity already we have seen in a previous lecture. We have considered 140-degree, and for that we have referred PSG 4.2, and we got the value of the percentage decrease in capacity is 0.08. That is 8% was there, but after dividing by the 100 we are getting 0.08. So let me open the PSG to show you the that part. Okay, every time we need that one. So today we are going to solve one or two numerical on basis of this first three formulas. Now chapter 4 is belong to the roller contact bearing. Chapter 4 जो है तुम्हारा that is belong to roller contact bearing. Page number 4.9, 4.4, and 4.2. This page you can find out the decreases in capacity at the higher temperature. If temperature is given, so with help of that you can find out the decreases in a capacity, and with help of this decreases in capacity you can calculate the value of KT. तो KT का फॉर्मूला ये है मेरे पास अवेलेबल. So with help of this you can find out the result. Basically we are taking the some factor, that factor is going to affect the equivalent load, so we are trying to multiply that factor. So ये factor multiply करके क्या आएगा, यहाँ पे I am considering that factor, that heat factor, to combine this radial and axial load, and after combining this axial and radial load we can proceed for the next step, that is nothing but the load life relationship. Here L10 is nothing but the standard rated life is L10. L10 is equal to C by P. C is nothing but the dynamic load. C is nothing but the dynamic load, and this P is nothing but the equivalent load. So L10 is nothing but the rated life. ये हमने already calculate किया rated life. So once you know this one, you can proceed with this one. If you are going to see a value of K is nothing but the constant for the ball bearing 3. हमने ये कहाँ मिला हमको, from the PSG page number 2 only, and for 10/3 for the roller contact bearing. So from PSG you can see here value of K. That value of K is nothing but the 3 and 10/3 equivalent. तो यहाँ से हम लोग क्या करेंगे, we can find out the life and load relationship. Suppose that if sometime value of life is given in a million rotation, L10 दिया है, and I want to convert this million rotation to in hours. मुझे L10 hours में कैलकुलेट करना है, और L hours to million rotation में कैलकुलेट करना है. L10 in a million rotation to hours और hours to million rotation कन्वर्ट करना है. So we can use the relationship formula between the million to hours. That formula is nothing but the L10. This formula is not available in the PSG, so you need to write this formula. Everywhere we need this formula. This is nothing but a 60 into n L10 in hours divided by 10⁶. So here n is nothing but the RPM. N is nothing but the RPM. What is RPM? That relation per minute, or you can say speed should be known. And after that L10 is nothing but the life in hours, rated life in hours. So we must know this two value, or if you know the million rotation then you can find out this one. Okay, so this formula is important to convert million to hours or hours to million everywhere. From first part or second part ये हमको ये formula लगने ही वाला है. So after proceeding with this one, what is the important part? Already we have seen this 4 important formula. First one is nothing but the how to find out the life L10 के respect में other life कैसे calculate करना है. We have already seen equivalent load life relationship, and after that we have seen the conversion. That conversion is nothing but the what? We have to convert the million to hours or hours to million. Now before the numerical, we must know the designations. How to write the designations of the bearing. Designation of the bearing. We must know how to write the designation. Suppose that if we have a 4 number of the bearing, this is my 4th number of the bearing, and that number is maybe whatever. So if we have a 4 number of the bearing, so how to read this bearing number? So in that case, last 2 digit, if that last 2 digit जो है, we need to first consider this last 2 digit and multiply with the 5. Multiply by 5. जैसे ये last 2 digit को we are going to multiply the 5, we'll get the shaft dia. Shaft dia means जो यहाँ पे inner race के अंदर जो shaft लगने वाला है उसका diameter you can find out from the PSG from the bearing number only. Okay, this is 3rd digit from the right side. This is nothing but the service, means this type of the service के लिए you can use. Now if this value is 0, 2, 3, 4. Just go through this number. There is not a 1. 1 यहाँ पे है ही नहीं. So this 0 is nothing but the extra light service के लिए we can use this 0. 2 we can use for the light service के लिए, and 3 we can use for the medium and moderate service के लिए, and 4 we can use for the heavy service. We can use the heavy service. So this, if this third digit is 0, 2, 3, 4, so 0 will represent the extra light service, and 2 will represent the light service, 3 will represent the medium service, and this one. This last, or you can say first digit from the left side, this is nothing but the indicate the type of the bearing. It is indicate the type of the bearing. Suppose that this digit is a 6. So this bearing is nothing but the deep groove ball bearing. Suppose that यहाँ पे जो ये नंबर है इसकी जगह पे 2 डिजिट आया, that 2 digit is nothing but the 22. So already we have written only 4, but there is maybe you can see यहाँ पे 0 एक डिजिट रहने वाला है. So when we are representing by 4. So first we need to take the 2, third one will be a type of service, and last जो भी 1 or 2 digit will be remaining, that is belong to the type of the bearing. If that number is nothing but the 22, so in that case you can say this is a spherical roller bearing. Suppose that that number is a 32, so that is nothing but the taper bearing. ये हमारा क्या रहेगा, taper roller bearing. So just we will go through with the example. यहाँ पे we are going to take the just example how we can identify. Just if I'm taking the example is nothing but the 6020. This bearing number is given. So how we can find out the things? If I'm going to multiply with this 2 digit with the 5, so that is going to be 20 into 5 means 100. This 100 is nothing but the shaft diameter. You can say this is nothing but the shaft diameter. This zero is nothing but the extra light service. Means this is applicable only for the extra light service. And if I'm going to see here, this is nothing but the 6. So this 6 is nothing but the deep groove ball bearing. We can see the same thing from the PSG. If I'm going to the table of different bearings, this all bearings are nothing but the escape bearings. Okay. If you are going to see here, so here this is nothing but the deep groove ball bearing. This is 60 series. यहाँ पे 6000 is nothing but the 1, 2, 3, 4. So we need to take care of this last two digits. So यहाँ पे 00 है, तो when we are going to multiply with the 5, okay, तो कितना होगा सर शाफ्ट डायमीटर? यस, कितना हो जाएगा शाफ्ट डायमीटर? According to our designation, if I am going to multiply, if I am going to through this one, so what would be the shaft diameter? 00 multiplied by 5. तो क्या होगा? 00 हो जाएगा. तो ऐसा होगा क्या? Is like that. So when I am just referring this one, तो यहाँ पे पता चलता है कि ये जो D है, D is applicable is nothing but the shaft diameter. But यहाँ पे 00 है. That time we are getting the shaft diameter is this one. Okay. अभी हमको यहाँ पे जब स्टार्टिंग के ये 3 बेरिंग 0, 1, 2, 3, when we are referring this one, so that time we are not able to get the shaft diameter. That shaft diameter is nothing but the D. यहाँ पे देखोगे तो you can find out the shaft diameter. तो 00 से पाई को मल्टीप्लाई किया तो यहाँ पे 0 होना चाहिए, but that is not possible practically. जब 00 वहाँ रहेगा तो बेरिंग किस हो सकता है क्या? That is not a bearing. So what we have learned regarding the resignation, that is not applicable to this 4. यहाँ पे we are need to refer this table to find out this shaft diameter. But after this you can refer कि 404 को multiply with the 5, you will get the 25 को if you are going to multiply the 25, when you are going to multiply the 6, 30, 7 से multiply करोगे 35, 8 से multiply करोगे 40, 45, 50, you can get. But that multiplication concept is not valid for this first, second, third and fourth parameter. Because when we are going to refer this 0, 1, 2, 3, that is not applicable. वो consider. Yes, this third digit is nothing but the 0, that is representing this bearing for the extra light service. Just after 60 series, when I am going to refer the second page, so I am getting directly 62. There is not a 61. So that's why I have written here that there is no one, that is a 62. One series is not there because that series is coming from 0 to 1, 0, 2, 3, 4. That is not a 0, 1. That is 0, 2, 3, 4. So if you are going to see here again ये फर्स्ट वाला जो है ये 4 के ऊपर अप्लीकेबल नहीं होने वाला है because that is not come under the designation. This is a special bearing, you can say. That concept is not applicable to find out the shaft diameter. So इसको 5 से मल्टीप्लाई किया तो यहाँ 5 का ही शाफ्ट होना चाहिए, बट यहाँ पे 12 है. So this starting वाला this 4 is not applicable to this concept. यहाँ पे ये जो concept है उसके, but after that, because here we are not getting the shaft diameter in term of 5, only accept this. So this power first 4 के लिए हम लोग को concept apply नहीं कर सकते, and for the rest you can apply. Similarly, you can see here after that we have a series 3. Again ये first वाले को छोड़ के rest के ऊपर you can apply. This is fourth series, that is 6-4. Again fourth से तुम apply कर सकते हो. Now this one you can see here self-aligned bearing. Self-aligned bearing. Now how to read this one? Self-aligned bearing. So first वाला जो ये 3 है इसको तो हमको छोड़ना है. ये स्पेशल फर्स्ट 4 बेरिंग इन ऑल टेबल इज अ स्पेशल कैटेगरी बेरिंग, दैट इज व्हाट नॉट अ स्टैंडर्ड शाफ्ट डायमेंशन के लिए नहीं है. आफ्टर दैट फोर्थ के थ्रू वी कैन गेट द स्टैंडर्ड शाफ्ट डायमेंशंस. यहाँ पे 4 है तो 20, 25, 30 ये विल गेट. So this first last 2 digit by multiplying the 5 will get the shaft diameter. This 0 is representing the this 2 is representing the service, and this last 2 is representing the self-aligned bearing. So here from this table you can refer the bearing number. ये यहाँ पे मेरा क्या represent कर रहा है 3 is nothing but the my medium service. Similarly you can find out the this is last 2 digit multiply by the 5, you can get the shaft diameter. हमको यहाँ से चालू करना है हमेशा 4 वाले से we can apply. But this 2 is nothing but the type of service. This 7 is nothing but the number for the single low angular contact bearing. So basically always we have a 4 digit. तो यहाँ से last 2 is multiplying by the 5 will get the shaft diameter. This third digit is representing the type of the service, and remaining 2 digit or 1 digit is mentioning the type of the bearing. So here 7 is mentioning this single low angular contact bearing. If you are going to refer there, this is single row only, but service is 3. Double row is going to be represented by 3. Cylindrical roller bearing we can find out by the table here. ये क्या लिखा था 22, and this one you can find out the all bearing series here. Double row cylindrical roller bearing, double row. This one is taper. Taper is starting with the 32. You can see here last 2 digit, this is service, and 32. So already we have referred that कि taper वाला किससे चालू होता है 32 से. So by the last 2 digit you can find out the type of bearing. But when we are going to apply, तो जो भी रहेगा that is applicable after 0-4 के बाद ही we can apply this one. First 3 or 4 bearings are special category bearing, so that shaft calculation is not applicable on that first 4 bearing. So when we are getting the 4 से ज़्यादा 3, 0, 1, 2, 3 आ रहा है, so that bearing के लिए we are not going to apply this multiplication of 5. So here by this bearing designation you can find out, because you know already we have studied while we are round off of the shaft diameter. हम लोग हमेशा उसको क्या करते थे, we are round off the shaft diameter always step of the 5. So step of 5 ने किया तो always we are getting the 10, 15, 20, 50. 20, 25, 30, 35 in term of 5. So always the shaft, standard shaft is going to be fitted in the bearing is always in term of 5. तो इसके पहले का जो 0, 1, 2, 3 है that time we are getting some special customized thing. So that is a different shaft dimension. So we need to refer that time. If we have a 0, 1, 2, 3, that time we need to refer the table, catalog table. Yes, anyone is having any doubt regarding the designation of the bearing, then please ask. This parameter is very important. Without this parameter, we are not able to solve. Yes, anyone? Yes, please say yes or no.
Yes, sir.
Any doubt? No? Okay.
No.
Okay. Now we'll see the guideline to select the bearing because we have a lots of bearing. अभी तुमने देखा रहेगा कि double row, single row, taper bearing, spherical bearing, and we have a deep groove ball bearing with the number of bearings. So guideline for selecting the bearing. This parameter is very important. Without this, we are not able to selecting type of bearing. First criteria is what? If radial load is less than or equal to 8 kilonewton, so in that case I can select the ball bearing. If our radial load is less than, or second condition, if our radial load is greater than or equal to, so you can see in both the cases if our load is 8 kilonewton, so we can proceed with the ball bearing or roller bearing, दोनों में से किसी के साथ जा सकते हो. If you are going to see here 8 kilonewton is combined in both, so you can go with the ball bearing or roller bearing if you have a load 8 kilonewton. This is only just simple guideline because when you are going to select the bearing, so that time we are getting lots of question कि कौन सा bearing लेना है. So if you have some guidelines, so accordingly you can select. If we have a small angular misalignment है मेरे पास, मीन्स थोड़ा सा मेरा जो शाफ्ट है that is not aligned with their axis, if we having some misalignment between their shaft and housing, so in that case we can select two different bearings. पहला तो मैं select करता हूँ self aligning bearing ताकि वो जो भी रहेगा that is going to be aligned by the self aligning bearing, or you can proceed with the spherical roller bearing. This is first. Now similarly when you are going to talk about the force, if combined loading आ रहा है, combined loading means there is a radial as well as axial. So यहाँ पे when we have a if combined loading but axial is a small, axial load is a small, so that time we can select B, G, B, B. That is a deep groove ball bearing. Okay. Fifth is nothing but the if rigidity is criteria. मतलब मेरे को rigidity के हिसाब से select करना है. Rigidity is a criteria. कहाँ पे लगता है rigidity? In a machine tool. यदि मेरे को machine tool वगैरह के लिए select करना है, so I need to select machine tool के लिए select करना है, तो हम लोग इसके लिए हमेशा रोलर बेयरिंग सिलेक्ट करने वाले हैं. Select always roller bearing if this is. Now if you are talking about the roller bearing में अभी you have a option, you have a PhD in chapter 1 में you can find out the lots of things to how to calculate the measurement. So roller में सबसे cheapest type of bearing is nothing but a cylindrical roller bearing. Okay, वो क्या करता है, वो रेडियल लोड भी लेता है, एक्सेल भी लेता है, तो इसलिए यहाँ पे रोलर बेयरिंग के लिए रिजिड कार्डिया टाइप यू कैन प्रोसीड विद सिलिंड्रिकल इनिशियली. तो सिलिंड्रिकल टेपर रोलर बेयरिंग की जगह पे हम जो सिलिंड्रिकल भी ट्राई कर सकते हैं बिकॉज दैट इज अ क्वाइट चीपेस्ट एज कम्पेयर टू ये टेपर रोलर बेयरिंग. तो वी कैन ट्राई टू फाइंड आउट कि भैया वहाँ पे सिलिंड्रिकल है अपनी बेयरिंग, इसलिए यहाँ पे सिलिंड्रिकल टेपर ऐसा मेंशन नहीं किया. द कैटेगरी इज मेंशनड इज अ रोलर, सो इट मे बी अ सिलिंड्रिकल रोलर और टेपर रोलर. So we need to find out. This last criteria is nothing but the to control the noise. Control the noise. You can select the DGP there. मेरा एक्सेल रेडियल लोड भी है and I want to control the noise. So in that case, I can use this DGBB a bearing. Okay, now if we are talking about last and very important parameter while selection of the bearing, suppose that bearing type is unknown. मुझे पता नहीं है कि वो डीप ग्रूव बॉल बेरिंग रहने वाला है, सिलेंडर डीप ग्रूव बॉल बेरिंग है, सिलेंडरिकल रोलर है, टेपर रोलर है, या सेल्फ अलाइन बेरिंग है, कुछ भी पता नहीं, इसमें से मुझे कुछ पता नहीं. And that time I want to find out the equivalent load. Suppose that if you don't know the type of the bearing, type is unknown, bearing type is unknown, and in that case if you are trying to find out the value of P, so how to calculate the value of P? In that case you can take the X into V into FR multiplied by nothing but the KE multiplied by KP. Now, sir, this formula and this formula, both formulas are different. If you are going to see here we have a X and Y. This X and Y parameter is nothing but the radial and axial parameters. And this parameter we can calculate only if we know the type of the bearing. So यहाँ पे if you know the type of the bearing, then only you are able to apply this formula. Because from the PSG, when you are trying to refer this value of X and Y, तो X Y कभी refer कर सकता हूँ मैं when we know the type of the bearing. So let me show you that table. .44 table. If you are going to see here, if you want to calculate the value of X and Y, that time you must know the type of the bearing. Type of the bearing, if you know, then only you can find out the X and Y. So if you know the type of the bearing, you can proceed with this formula. That formula is given in a question only. You can proceed. Suppose that if you don't know the type of the bearing, question में सिर्फ load requirement दिया है, we need to calculate which bearing is suitable. That time type as well as other parameter like X and Y we need to calculate. In that case, मेरे को जब तक type of bearing पता नहीं है, I am not able to do the equivalent. So in that case, I can use this one. In this one, I can take the X is equal to 1 because this is the equivalent formula without this. So you can say here we are trying to find out the one lump sum equivalent. Once I will define the particular bearing, so वो particular bearing को define करने के बाद I will apply that previous वाला formula. कि एक मुझे आइडिया आ जाएगा कि here deep grip ball bearing may be suitable, cylindrical will be suitable, taper will be suitable. Once I will get the type of the bearing, then I will apply that previous वाला formula. P is equal to XV Fy plus YFA SKT. वो वाला formula apply करूँगा. Once we confirm with the type of the bearing. If this type of the bearing is unknown, in that case, you can use this formula. Here, K is a very important factor. That K is playing the importance of the ये जो Ke है, it is going to give you the effect of the axial loading because here axial loading parameter is unknown. So we are just putting the K equivalent 1.2 if FA upon FR का value less than 0.3 आता है because if you know the FA and upon FR and that ratio is less than 0.3, you can take the 1.2 because axial and radial का X and Y parameter मुझे निकालने का option नहीं था. I will tell you कभी ये use करने का है. Just please write down these equations. This equations is available in a Bhandari only. This is not available in a PSG. So you must know these values to get the idea when we don't know the value of when we don't know the type of the bearing. So 1.5 if FA upon FR is a greater than 0.5. So these three values you must know. This formula is applicable only when type of bearing is unknown. Okay. So ये फॉर्मूला और जो पीछे वाला फॉर्मूला, दोनों फॉर्मूला लगेगा मेरे को जब मेरे को टाइप ऑफ बेरिंग अननोन. इफ टाइप ऑफ बेरिंग इज नोन, so directly we are going to proceed with this formula. If we don't know the type of bearing, so initially I will calculate the type of bearing with this formula, and once you get the type of the bearing, and we'll apply that previous other formula to get the other values. Okay, so हम उसको by the numerical we can see. Now we'll go with the first numerical, and after that we will get the idea how to apply the things. Example number 1. I'm just writing, and from next time I will put it on the PPT. Time बचेगा थोड़ा सा. Determine the expected life in hours. In hours of SKF bearing number 22216 if it is subjected to an axial load of 20 kilonewton and radial load of 80 kilonewton. Outer race rotates at 65 rpm. The operating temperature is 140 degrees Celsius, and probability of survival is 92%. Take service factor 20%. Yes, this is the question. This is a university question. Determine the expected life in hours. Basically, what we need to do, we need to find out the expected life in hours of SK bearing for 92% survival. Means you can say, if I'm going to go through the question, so once we get it, we need to find R92 के लिए मुझे L08 find out करना है. Basically, what we need to find L08 means when we have a probability of survival is 92, that time life will be 08. So probability of survival is 92, reliability is 92. That time I want to find out the expected life. That's all. That expected life is nothing but the 0. They have not asked you calculate the rated life. That rated life is L08. तो वो पूछा नहीं है. If I am going to see the given data, so that they have given the bearing number. Bearing number is given, that is a 22216. So by multiplying by this 2 digit, you will get the shaft diameter. This is nothing but the light service, and this is nothing but the 22 is nothing but the already just मैंने बोला था that 22 is nothing but the spherical roller bearing. So this bearing type is known. This bearing type is known. कि this bearing is nothing but the spherical roller bearing, and this 2 is nothing but. So by this bearing number, one thing is what we know the type of the bearing. मुझे type of the bearing पता है. Okay, let it be. F A का value दिया है. What they have given axial load is a 20 kilonewton. Just writing 20 kilonewton. And FR is given. That is nothing but the 80 kilonewton. 80 kilometer. Now after that, outer race is rotating. Outer race rotates. Outer race means value of v is going to be 1.2. Already we have discussed कि भैया जब भी v का बात आएगा तो outer race rotate हो रहा है तो 1.2 we need to take. So this in this application outer race is rotating. So outer race के टाइम पे this v का value should be 1.2. Now rpm is known, that is nothing but 65 rpm. ये भी दिया. Temperature is given, that is a 140 degrees Celsius. Now probability of survival 92 is given. निकालना है मुझे. Take the service factor. Service factor is 20%. Means we need to take the 1.2. Service factor जो लेना है, that is we need to take the 2. That is going to be 1.2. So the service factor is now. So before moving the things, यहाँ पे मुझे एक चीज तो पता है कि what is the things is nothing but the bearing number 22216. So I can write here bearing number 22216. I need to go to the PSG and I need to search this bearing number to find out the value of C and C0. The C and C0 is nothing but the dynamic and static load carrying capacity. So our full focus is around this two parameter. So let us go to the PSG and this cylindrical roller bearing, spherical roller bearing maybe 30 के पेज नंबर 4.30 के आसपास मिलेगा मुझे. Series, yes, 222 series. This is a 222 series speaker roller bearing. So speaker roller bearing is available here. So we need to go to here. So you can say there is no special bearing. कुछ भी special bearing directly starting. So multiply by the 5 you can. So our bearing number is this 22216. So for that you can see here this two things is given कि भैया basic capacity, static capacity and dynamic capacity. So dynamic capacity is a 15,300 kgf. This unit is very important. So let me write 14,000 and 15,300. So this is a 14,000 and this is a 15,300. 15,300 and it is a kgf. kgf. So if you are talking about the kgf, तो मैंने बोला नहीं हमको सब यूनिट न्यूटन में था तो I can write 530 जीरो की जगह पे आई कैन
एक और जीरो आएगा ना सर.
क्या था बेटा वहाँ पे
kg force to force
न्यूटन
जाना है.
न्यूटन जाना है न्यूटन. ओके एंड इट इज गोइंग टू बी 1400040 न्यूटन. नाउ वी हैव रेफर दिस पैरामीटर दिस वन यहाँ से रेफर किया. तो बाय द बेरिंग नंबर एक चीज तो मुझे पता चल गया स्टैटिक एंड डायनामिक कैपेसिटी. ओके लेट्स मूव टू द फर्दर पार्ट. Now we'll try to find out the equivalent load. P का वैल्यू फाइंड.
पेज नंबर क्या था?
ESG में 4.
ओके सर.
और ये this is nothing but the ESG 4.32. Now we need to find out the equivalent load. मुझे क्या निकालना है? मुझे रिलायबिलिटी 92 के लिए L08 निकालना है. तो बेसिकली मेरे लिए क्या यूजफुल है मैं अभी वो देख लेता हूँ. पहले मेरे लिए ये वाला फॉर्मूला यूजफुल है. विच फॉर्मूला? दिस फॉर्मूला. यही एक फॉर्मूला है जहाँ पे मैं 08 डाल सकता हूँ और इसको 92 डाल सकता हूँ. तो ये फॉर्मूला यूज करने के लिए मुझे बी पता है. यस आई नो दिस. ये मुझे पता है. यस आई नो दिस. इफ आई नो दी L10 देन ओनली आई कैन फाइंड आउट दिस L08. तभी मैं निकाल सकता हूँ L08. तो ये L08 निकालने के लिए मुझे L10 निकालना है. तो मैं फोकस टू कैलकुलेट द L10 बिकॉज वन फॉर्मूला यही एक फॉर्मूला है वेयर वी कैन फाइंड आउट द लाइफ 08 दैट इज नथिंग बट द रिलायबिलिटी ऑफ 92%. Okay, if reliability is 92%, life will be L08. So basically I want to calculate the L08. तो L08 के लिए we must know the L10. तो L10 निकालने के लिए हम लोग अभी सब कर रहे हैं. So L10 के लिए if I am going to see this formula, so if you know this P का value, C already we know that because already we have know the varying number. तो पता है, C पता है, P पता है, K already that is depend on the ball bearing और roller bearing, ये भी पता है. तो if I am getting the value of P, so easily I can get the L10. Once I can get the L10, so I will put there L10 and I will try to find out the L08. तो मेरा ये जो है इस फॉर्म में चल रहा है, तो C मेरा मिल गया यहाँ पे. Now I will focus to the L value of P. That value of P is nothing but the equivalent load. मुझे अभी equivalent load निकालना है. So I can write कि भैया स्टेप नंबर 2 बोल दो या इसको मैं स्टेप 1 बोल देता, यहाँ से चालू किया तो इन स्टेप we need to do the calculation of P or equivalent. Equivalent load P we need to calculate. When we are talking about the equivalent load, ये हमको equivalent load निकालना है. So equivalent load का formula we know that is a P X into V into FR plus Y into FA into S into KT. This is the formula. So we try to get the value one by one. तो V का value मेरे को यहाँ पे पता है. Let me write the values. V is equal to 1.2 because outer S is rotating. S का value पता है because already it is given. KT, yes, I can calculate the value of KT. So first we'll try to get the value of KT. KT is nothing but the 1 upon 1 minus percentage decreases in capacity. So that KT का value क्या होएगा? We need to check that 1 upon 1 minus percentage decreases for temperature is equal to 140 degree. 140 के लिए we need to check the PSG. Is at page number 8. ठीक है. Now we are going to take यहाँ पे 5, 10. अच्छा तो ये है, तो यहाँ पे 140 के लिए क्या होगा? 130 के लिए 6, 135 के लिए 7, 140 के लिए 8. So that is going to be 148. ये 140 के लिए 8. So here we need to put this 0.08 because 140 के लिए जो आ रहा है मेरा 8% decrease in capacity. So just tell me the value of KT. Yes, what is the value of KT? KT का वैल्यू कितना आ रहा है?
1.0869.
1.0869.
हाँ सर.
Yes, ठीक है. चलो, this is our value. Now we know the 1.0869. Okay. After that, ये पता चल गया, ये पता चल गया, ये मुझे पता है, ये मुझे पता है, ये पता है. Now x and y is there. So we'll try to find out the x and y. So x y के लिए basic equation number 4.4. The 4.4. Let me decrease this something. This is a 4.4. बेरिंग कौन सा है? यस, स्प्रिंकल रोलर बेरिंग है. स्प्रिंकल रोलर बेरिंग. ओके, दिस इज द, ये पता है करके मैं यहाँ पे एक्स वाई निकाल पा रहा. यदि बेरिंग टाइप नहीं पता होता था तो मैं इक्विवेलेंट के टाइम पे ये एक्स वाई नहीं निकाल पाता था, इसलिए मुझे वो पुराना वाला फॉर्मूला यूज करना पड़ता था जो हमने के इक्विवेलेंट लिया था, वो फॉर्मूला अप्लाई करना पड़ता था. लेकिन यहाँ पे मुझे पता है कि बेरिंग टाइप क्या है, सो दैट्स व्हाई आई एम रेफरिंग दिस वन. सो फर्स्ट इफ आई एम गोइंग टू सी हियर वी मस्ट नो द वैल्यू ऑफ ई. E क्या होता है? दैट इज नथिंग बट द रेशियो ऑफ दिस टू, FA upon FR. So मैंने बोला FA upon FR we can calculate. So let's go and calculate the FA upon FR. FA upon FR. Yes. What is FA upon FR? 20 divided by 80. कितना आ रहा है?
0.25.
Now we are getting 0.25. Now we'll go to here. now if I'm going to see our bearing number, तो मेरा bearing number इसके बीच में आता है. My bearing number is come between 10C to 20C. Range is 5 to 7, 8 to 9, 10 to 20. और bearing number is और triple to 10, triple to 20. तो यहाँ पे triple to 16 will lie between this 10 to 20. Now if I'm going to see here, E का value is a 0.23, but our E का value is a 0.5, but our ratio value is a 0.5, 0.25. So हम लोग यहाँ पे जाके चेक करेंगे कि E का value is less than FA upon FR. तो our FA upon FR is nothing but the 0.25. हमने अभी just calculate किया यहाँ पे 0.25. So I'm going to just put the FA upon FR here. तो E का value कितना है उस केस में? E का value है 0.23. So this कॉलम वी नीड टू रेफर. यदि मेरा 0.23 से कम होता था या इक्वल होता था एफ ए अपन एफ आर का वैल्यू, सो इन दैट केस आई कैन रेफर दिस कॉलम. सो यहाँ पे इफ आई एम गोइंग टू रेफर द कॉलम, सो आई कैन फाइंड आउट कि भैया एक्स फैक्टर इज 0.67 एंड वाई फैक्टर इज 4.4. हाउ आई हैव रेफर्ड? फर्स्ट आई हैव कैलकुलेटेड दिस एफ ए अपन एफ आर रेशियो एंड वी नो द बेयरिंग नंबर. तो बेयरिंग नंबर के हिसाब से वी गॉट द वैल्यू ऑफ ई. Once we have compared the FA upon FE, FA upon FR with the E, so after comparing these two values, we are getting the FA upon FR is greater than E. So if FA upon FR is greater than E, so in that case, this is feasible for us. So here, X का value will be 0.67. X value is going to be a 0.67 and Y is going to be a 4.4. 67, yes. 67, correct. 67 and 4.4. Now we'll try to find out the things. Here,
सर बट
what
ये 0.27 से कम भी तो हो सकता है ना, लाइक इन दैट केस.
what which value बेटा?
कैन यू गो बैक टू पीडीएफ?
Yes. Yeah.
हाँ, तो 0.27 वाला जो लाइन है,
0.27 वाला बेटा.
हाँ, तो इन
But-
दैट केस हम
But
हाँ,
that
तो
is
रेशियो
not
से कम होगा
that is
ना.
लेकिन बेटा that time our bearing number is what? bearing number क्या है अपना? 216. वो ये दोनों के बीच में आता है क्या बेटा? ये दोनों के बीच में आता है 16.
ओह अच्छा, ओके.
यहाँ पे ये देखो, ये क्या है 222 और यहाँ पे भी क्या रहेगा 222. तो 222 222 इसके बीच में ही हमारा 222 आने वाला है. सो इन दैट केस आई कैन यूज ओनली दिस रो.
ओके सर,
गॉट इट? Okay, now we need to go here and we'll try to now we'll try to put the values. P is equal to X, I am 0.67, V is 1.2. now किलो न्यूटन का था, हमको P न्यूटन में निकालना है बिकॉज ऑलरेडी C को मैंने न्यूटन में कन्वर्ट किया. सो दिस 20 था FR का वैल्यू, तो हम लोग 20 है FR का वैल्यू. कितना है FR? FR is 80.
FR is 80 and FA is 20.
20 into 83 plus 4.4 into 20 into 10 is to 3 multiply by 1.2 multiply by 1.0869. Now just calculate the value of P.
So 19,198,667.
198
667.92.
667.92 Newton. Okay, done. So we have got the value of P. P का वैल्यू हमारा मिल गया, काम हो गया. Now once you will get this P, we know the value of C. दोनों न्यूटन में है. I will apply the load life relationship. L10 is equal to, that is nothing but this one, C by P वाला formula. Where's that formula? ये वाला C by P raised to K. So that is a C by P raised to K. So first we need to define the value of K. So this is nothing but a spherical roller bearing. Spherical roller bearing है तो K का value is going to be 10 by 3. Now C का value was ये 15,000 था, उसको हमने कन्वर्ट कर दिया था न्यूटन में, एंड P का वैल्यू आया 198,667 667.92 Newton. Now just put the values and try to get the value of L10. That is step number 3. क्या किया था लास्ट टाइम? स्टेप 2 किया था, स्टेप 2 तो स्टेप 3. What is the value of L10?
0.418.
0.418. 0.418, and unit is always million rotation. 0.418. Now in step 4 we'll try to find out the L08. So in that case life bearing formula you can use. तो अभी हम लोग क्या करेंगे, L upon L10 is equal to 1 upon R divided by 1 upon R90 raised to 1 upon B. तो यहाँ पे B का वैल्यू मुझे पता करना है. B के लिए यहाँ से भी फॉर्मूला उठा सकते हो, कोई प्रॉब्लम, यही फॉर्मूला है. हम जो यहाँ से ये फॉर्मूला प्रोबेबिलिटी ऑफ सर्वाइवल निकाल रहे हैं. प्रोबेबिलिटी ऑफ सर्वाइवल निकाल ही रहे हम लोग 92 के लिए. उससे पूछा ही था प्रोबेबिलिटी ऑफ सर्वाइवल 92 के लिए. सो हियर B का वैल्यू इज 1.17 एंड फॉर डीप ग्रुप बेरिंग यू कैन टेक दी 1. मेरा डीप ग्रुप बॉल बेरिंग तो नहीं है, आई कैन टेक द P इज इक्वल टू 1.17. डीप ग्रुप बॉल बेरिंग रहेगा तो ही मैं वो लूंगा 1.0, अदरवाइज एवरी टाइम आई एम गोइंग टू दिस. नाउ if I'm going to put this values, so I can find out the things. So L08 basically I want to calculate. This value is known 0.418 पता है मेरे, ठीक है. ln 1 upon this is going to be 0.93 92 8 है तो 92 divided by ln 1.90 raised to 1 upon 17. Now just calculate the L08. कितना आ रहा है?
Uh, 0.342
0.342 million.
million.
No, this is the answer. But in the question, they've asked the life in hours. They not asked the life in a million rotation. So I need to convert this life hours to million rotation. So we have a formula कि million rotation को हम लोग 60 into n L hours divide by 10⁶. Just हमने अभी थोड़ा टाइम पहले बात किया था, वो सेम फॉर्मूला we are trying to apply this one. सर यहाँ पे L10 दिया था, यस दिस फॉर्मूला यहाँ पे L10 के लिए था, तो L10 मिलियन L10 आवर्स. नाउ L08 is going to be replaced. So here we can write this formula 08 के लिए. तो L08 मिलियन रोटेशन is equal to 60 into n into L08 hours divided by 10⁶. 10⁶. So this value is known 0.342 and ये मुझे निकालना है. ये वैल्यू मुझे दिया है क्वेश्चन में RPM 65 is given 65. दिस वैल्यू इज
87 hours
87 डेसिमल में कुछ है बेटा?
0.74. हाँ सर 0.743.
3 hours. This is the answer. This is the answer. लगता है क्या टफ है ये? Do you think it is tough?
ना कम आ रहा है, लाइक 87 hours में वो बेयरिंग चेंज करना पड़ेगा.
हाँ, जो बेरिंग चेंज नहीं करना पड़ेगा. ये क्या बोल रहा है कि जब मैं 92% का प्रोबेबिलिटी चेक कर रहा हूँ तो कितने टाइम तुमने रन किया था बेटा? 92% प्रोबेबिलिटी मिला तो कितने टाइम तक बेरिंग रन किया था तुमने लाइफ निकालने के लिए? ये इतने लाइफ के लिए निकाला है, इतने आवर्स के लिए हमने लाइफ निकाला था जिसमें हमको प्रोबेबिलिटी कितना मिला था? 92%.
ओके
ओके, सो वी हैव टेस्टेड दिस मच आवर्स एंड उस समय मुझे कितना मिला. यहाँ पे ये देखोगे तो तुमको पता चलेगा. इफ यू आर गोइंग टू कन्वर्ट दिस वन इन आवर्स तो तुमको पता चलेगा L10 कहाँ गया. इफ यू आर गोइंग टू कन्वर्ट दिस L10 देन यू कैन फाइंड आउट कि कितना टाइम रन करने के बाद मुझे ये L10 वाला केस मिला. 90% उतना टाइम में बेरिंग को रन करूंगा तो 90% बेरिंग सेफ रहेगा.
ओके
ओके, यस,
गॉट इट.
दिस वाज द क्वेश्चन. बेसिकली ये एक्चुअली इनिशियली हम लोग एक्चुअली जो क्वेश्चन सॉल्व करते हैं ये हमारा दो टाइप का क्वेश्चन आता है एग्जाम में हमेशा. पहला, मैं जस्ट आई एम गिविंग द टाइप, आफ्टर दैट आई विल क्लोज द थिंग्स. पहला आता है मेरा बेटा कांस्टेंट लोडिंग. कांस्टेंट लोड, इसमें मेरा दो टाइप का क्वेश्चन आता है. ओके, मतलब पहला बेरिंग नंबर विल बी गिवन, bearing number given, and we need to calculate the rest parameter. And in second case, life and other parameters will be given. Other parameters will be given. We need to calculate the bearing number and type. So this is the second one. यहाँ पे मुझे ये कैलकुलेट करना है. So जो अभी हमने सॉल्व किया ये क्वेश्चन, दिस बिलोंग टू द बेरिंग नंबर इज गिवन. बेरिंग नंबर दिया था, हमने बाकी पैरामीटर कैलकुलेट किया, लाइक L10, L08 ये सब कैलकुलेट किया. सेकंड टाइप विल बी बिलोंग टू व्हाट? लाइफ एंड अदर पैरामीटर विल बी गिवन. बाकी सब दिया हुआ रहेगा, सिर्फ तुमको बेरिंग नंबर निकालना. सो व्हेन यू आर गोइंग टू कंपेयर द थिंग्स देन यू कैन फाइंड आउट दिस टाइप इज क्वाइट डिफिकल्ट. ये वाला सेकंड टाइप जो रहेगा, दैट सेकंड टाइप विल बी क्वाइट डिफिकल्ट रहने वाला है, क्योंकि we need to go with the second type of the formula जो हमने बात किया था. बेरिंग नंबर नहीं दिया रहेगा तो K इक्विवेलेंट टर्म यूज करना. वो सेकंड जो टाइप एग्जाम में बहुत पूछता है, दैट इज नथिंग बट द वेरिएबल लोड. इसमें भी दो टाइप, बेरिंग नंबर गिवन एंड नीड टू कैलकुलेट अदर पैरामीटर्स. यहाँ पे लाइफ एंड अदर पैरामीटर विल बी गिवन एंड यू नीड टू कैलकुलेट bearing. So right now we are discussing about the constant loading parameter. ये हम लोग constant loading मतलब यहाँ पे throughout this cycle my load is a constant, radial and axial load is constant. जितने टाइम के लिए रन कर रहे हैं load and axial and bearing, axial and radial load is a constant, change. When we are going to see the analysis of the variable loading, उसमें क्या होएगा? थोड़े टाइम बाद 10 सेकेंड बाद radial axial load change, कुछ आरपीएम के बाद रेडियल लोड आरपीएम चेंज, आरपीएम फ्लक्चुएट होएगा. सो दैट टाइम हाउ वी कैन डिफाइन द वेव, दैट कम अंडर सेकंड पैरामीटर. ओके, सो वी हैव स्टार्टेड विद राइट नाउ दिस वन एंड आफ्टर दैट विल गो. इफ यू नो दिस पार्ट यू कैन प्रोसीड विद दिस. यदि यहाँ पे कुछ नहीं आता तो यहाँ पे कुछ नहीं आएगा. ठीक है, तो ये पहला, यदि दोनों केसेस आता है तो ये दोनों केसेस कर सकते हैं, बिकॉज हियर आई एम गोइंग टू वेरिएबल को इक्विवेलेंट करने के लिए आई एम गोइंग टू सिंपली यूज वन फॉर्मूला एंड रेस्ट प्रोसीजर विल बी एज इट इज फॉर एप्लीकेबल जो कांस्टेंट लोडिंग के लिए. सो बी केयरफुल विद दिस टू मेथड्स. यदि ये तुमको अच्छे से आता है तो ये दोनों तो आने ही वाला है. ओके, लेट मी टेक द अटेंडेंस. इफ यू हैव एनी डाउट सो यू कैन आस्क. किसी को कुछ डाउट है तो प्लीज आस्क.
सर
यस बेटा.
तो मतलब हम लोग ये बेसिकली पीएचडी में से जो वैल्यूज होते हैं वो लाइक फॉर्मूला वाइज ले लेते हैं, बट पीएचडी में काफी सारे ग्राफ्स होते हैं, उनका क्या यूज रहता है? लाइक हाँ एप्लीकेशन वाइज लाइक आज अभी तक हम लोग ने वो कभी यूज नहीं किया ना ग्राफ, इसलिए पूछ रहा हूँ।
करोगे ना बेटा, अभी तो चालू है, अभी डीएमएस बाकी है पूरा।
ओके सर।
अभी डीएमएस बाकी है बेटा, अभी तो सिर्फ MD2 है। जब वी आर गोइंग टू डिजाइन सिस्टम्स, समझे ना, सो वी आर गोइंग टू यूज मोस्ट ऑफ टाइम। क्या होता है बेटा, जैसे तुम मटेल का देखा तुमने, हमने एक 723 में एक लाइन ये यूज किया था। वैसे बहुत सारे चीजें हैं ना जो हम यूज करने वाले हैं। 100% नहीं यूज कर सकते क्योंकि हमारे पास 100% सिलेबस में ही नहीं, समझे। बट बहुत टाइम टेबल एंड ग्राफ दोनों दिया रहता है, ठीक है, तो वहां से भी हम रेफर करते हैं। तो 100% नहीं, लेकिन हम लोग यूज करने वाले हैं।
ओके सर, चलेगा।
Yes, let me take the attendance. Now you can leave the meeting. इसमें पता चलता है कि यस बेटा, इसमें पता चलता है कौन सो गया है। लास्ट में बहुत लोग रुक जाते हैं। चलो बाय एवरीवन।
बाय सर।